3 hearts, blue blood, 9 brains. The octopus is less of an animal and more of a biology exam that nobody studied for. Today we are answering one specific question. Why 3 hearts? And the answer involves copper, deep sea survival, and the fact that the octopus heart literally stops working every time it swims. We will get to that, strap in. Let's start with the blood, because the blood is the whole reason the hearts exist. Your blood is red, you know this. It is red because it uses a protein called hemoglobin, which contains iron, and when iron binds to oxygen, it produces that familiar red color. Hemoglobin is excellent at carrying oxygen. It is efficient, it is reliable, and for most animals living in warm, oxygen-rich environments, it does the job beautifully. Octopuses, however, looked at hemoglobin and said, no thank you. Instead, they use a protein called hemocyanin, which is copper-based. When hemocyanin binds to oxygen, the copper turns it blue. Not navy blue, not a hint of blue, genuinely, properly, actual blue blood. And when it loses its oxygen and becomes deoxygenated, it turns completely transparent. The octopus is literally running on blue, invisible blood, and nobody talks about this enough. But here is the catch. Hemocyanin is, by most measures, a significantly worse oxygen carrier than hemoglobin. It is only about a quarter as effective as hemoglobin at transporting oxygen under normal conditions. That is not a minor efficiency gap. That is the biological equivalent of choosing to water your entire garden through a cocktail straw. So why would evolution go with it? Because octopuses do not live in normal conditions. In the cold, low-oxygen waters of the deep sea, hemocyanin actually outperforms hemoglobin. Species like the Dumbo octopus thrive in freezing, oxygen-poor depths precisely because their blood chemistry is optimized for those conditions. What looks like a disadvantage on a tropical reef becomes a serious survival advantage 3,000 feet down. Cold, deep ocean water is where octopuses evolved, and hemocyanin is built for exactly that environment. It grips onto oxygen molecules in conditions where hemoglobin would struggle. The trade-off is that in warmer water it becomes less efficient, which incidentally is why octopuses are particularly sensitive to rising ocean temperatures as climate change progresses. Their blood is finely tuned to a cold ocean. A warming ocean is genuinely bad news for them at a physiological level. So the blue blood is not a flaw, it is a specialization. A very extreme, very specific, very effective specialization for living in one of the harshest environments on the planet. The problem is that hemocyanin also makes the blood significantly thicker and more viscous than ours. It requires great pressure to pump it around the body. Blood pressures can surpass 75 millimeters of mercury. The heart you have was never going to cut it. You need more. Enter the 3 hearts. 2 of the hearts work exclusively to move blood past the animal's gills, where it releases carbon dioxide and gains oxygen. Then the 3rd heart circulates that oxygen-rich blood to the organs and muscles. Think of it as a relay system. 2 dedicated gill hearts, called branchial hearts, receive deoxygenated blood returning from the body and push it through the gills for a fresh oxygen top-up. That freshly oxygenated blood then goes to the systemic heart, the main heart, which pressurizes it and fires it around the rest of the body. Arms, organs, brain, all 8 arms worth of mini neural clusters, the whole operation. 3 hearts, working in rotation, generating enough pressure to push thick blue blood through the entire body of an animal that has 8 arms, 9 brains, and no skeleton to support any of it. The system is elegant precisely because it is distributed. No single heart has to do everything. Now, the swimming problem. Here is the part that sounds like a joke but is entirely real. The systemic heart, the main one, the one pumping blood to all the organs, stops beating when the octopus swims. When an octopus uses jet propulsion to move through the water, it draws water into its mantle cavity and then forcefully contracts the muscles to expel it. That powerful contraction also compresses the veins returning blood to the systemic heart. With reduced blood coming in, the heart does not have enough to pump out, so it temporarily stops. The octopus is quite literally swimming itself into a temporary circulatory shutdown. Every time. Which explains why, despite being capable of jet propulsion, octopuses overwhelmingly prefer to crawl. Swimming tires them out almost immediately because their main heart keeps switching off. They have evolved a spectacular escape mechanism that is so physiologically costly, they try to avoid using it. This is both incredible and extremely relatable. 3 hearts, blue copper blood, a circulatory system so pressurized it can sustain life in water cold enough to freeze most creatures solid, a swimming mechanism that is simultaneously brilliant and self-defeating. The octopus did not accidentally end up this way. Every single one of these features is the result of hundreds of millions of years of evolution producing solutions to the specific, brutal problem of living in the deep ocean as a soft-bodied, boneless, active predator that needs oxygen and has no obvious way of getting it efficiently. The 3 hearts are not a quirk, they are the answer. The octopus, as one cephalopod researcher famously put it, is an alien. And honestly, with 3 hearts pumping blue blood through 9 brains to 8 independently thinking arms, it is very hard to disagree. And subscribe because the natural world has a lot more of this waiting for you.